And we're back. My name is Seth Juarez from Channel 9. I'm here with the awesome Philip Carter. We're going to be talking about FSharp for the practical developer. Is that right?
Yes, yes. This is FSharp for the practical developer.
So most people are like, hey, but FSharp isn't so practical. It's for scientist people. And you're here to totally debunk that myth today, right? With real stuff.
Precisely. So FSharp kind of has this, there's this misconception going on that you got to be some kind of genius to use it. Or, you know, it's for finance, for processing billions of transactions. And like, yes, people do use it for that. And people do use it for data science, but people use other languages for that as well. You can do basically just normal stuff with FSharp. You can create web services, console apps. You can basically do anything that you wanted to do in C# or VB. You could also do with FSharp. And I think that's something that could use a bit more emphasizing.
All right, well, let's dive in, bud.
Yeah, absolutely.
By the way, if you have any questions, we're taking questions live, so please put them in the question box just below, and we'll answer them as soon as we can. All right, let's do it.
Absolutely. Okay, so first, I think I'll probably start with a really brief introduction to FSharp.
Okay.
So FSharp is what we like to call a functional-first multi-paradigm programming language. That's a lot of fancy words for basically does whatever you want, but with a functional programming twist to everything. Or at least that's kind of the first way that you do things. It's mature, so we're on FSharp version 4.0. It's been around for a long time. It's very stable. It's open source. It's developed on GitHub. On github.com/Microsoft/Visual FSharp. That's where the Visual FSharp language and tooling is actively developed on. And it's cross-platform. It runs on Mono, and we also have an alpha version running on .NET Core. There's still a little bit of work left to do, but we anticipate getting full support pretty soon. And there's also a github.com/FSharp group that you can see. Now, organization. And this organization has a lot of really awesome stuff in it. So there's the open source version of the FSharp compiler there. There's a lot of tooling, like build orchestration tooling. There's a really awesome library called FSharp.data, which has tons of different ways to access data and things like that. FSharp is strongly and statically typed. So basically, it's like C# and VB. You compile it ahead of time. It compiles into MSIL, and that runs on .NET. However, it also comes with type inference. And so basically, you don't need to explicitly list all the time, like, you know, oh, this is an int, this is a string, or something like that. The compiler is able to figure out a ton of stuff for you. And so that leads to a lot less overall code and a lot less boilerplate code. And so when you have a larger system, that's actually quite useful because that's just less cognitive load as a whole. It also supports scripting and REPL-driven work. So that's basically like, say you're building something and you have like a prototype. You're just kind of prototyping it out, or you're not quite sure where you want to go. You just kind of write some code, run it in a read evaluate print loop that we have called FSharp Interactive in Visual Studio, kind of see what happens, play around with it a little bit more, and you can kind of build your way towards something like that before you do things like seriously. But you can also use it for scripting. So a lot of times people create console apps for like a really one-off utility or something like that. You can do that with FSharp scripting instead. And that's a pretty cool thing. And then there's also really powerful core libraries with FSharp.core. This is sort of like a mini standard library that comes with the language. It's got async programming constructs, which predate async await in C# and VB, by the way.
Wow, they always tell us this, man. We had it first, people. I love it.
We did, and it's great. It's really awesome. You'd love it. It has message passing with what's known as an actor model kind of built in. That's kind of for when you have highly concurrent scenarios and you just want to pass data back and forth between lots of different things. I'm calling it data wrangling, but just general data processing stuff. There's a lot of really nice utilities there, like list processing, all that kind of stuff baked in there. So when you have your information, you can do basically anything you want with it with the core libraries. So let's see some code.
Let's do it. Let's see. You made a lot of promises. Let's see if we can pay it off.
I'm making a lot of promises. Well, first, I'm just going to start off with something dead simple because this is a brief introduction to FSharp right now.
Okay.
So this is basically the simplest that it gets, a hello world. It's not really that interesting. Whoops. So if I were to open the system namespace, then I get access to things in system, like say console.read. And so in this case, I'm ignoring .read. This is kind of a special thing with F# where console.read actually returns an int. Most of the time people just kind of ignore that in C#, and you can silently ignore that in here. Well, sometimes that actually can give you a little bit of a bug if there's a particular thing that you happen to ignore. In F# you need to explicitly ignore stuff if you know that you don't really care about what's being returned here. And so this is just to start it up and run it, and we can see once this thing actually builds and compiles, it will say, hello world, ta-da. That is beautiful, but not all that interesting.
Right.
So let's define a function, because F# is about functional programming. So you do that using the let keyword. So we'll go let square x equal x times x. Computes the square of a number. So we can modify this, and we'll just say, I don't know, square of %d is %d. So this is a little format string that I got going on here. Let's pass in 12, and we'll go square of 12. Kind of see what that looks like. Compile and run again.
And then we should see.
We should see it. It says 12 is 144. Hooray. Now, that's not all that fast, having to hit play and do the compile thing again and again and again. Kind of annoying. So let's start a little interactive session. And I'll just highlight this guy right here. And I'll hit Alt-Enter. And that'll execute it in this interactive window here. So now we have access to square. So I can go square 12. Ta-da. It's right there. So let's define another function here.
Okay.
I'll define it as isOdd. X mod 2 is not equal to 0. This mod 2, that's just a isOdd check. That's how you do not equals in F#. Let's go ahead and send that over to the interactive window.
And to send it over, you're just highlighting and pressing Shift-Enter?
Oh, yeah. So another thing that you can do is you can right-click and then say Execute in Interactive.
It's Alt-Enter. There you go.
Oh, Alt-Enter. Yeah, sorry. But I don't like right-clicking. I just like keywords and stuff.
No, it's much faster.
So let's do this. IsOdd square 12. That'll be false. That makes a lot of sense. We do square 12 plus 1. Now it's true because that's 144 plus 1.
Yep.
And okay, that's pretty nice, but still we're not really, I mean, these are functions, this is kind of cool, but this is really simple stuff. So let's say we wanted to take a list of numbers and then find the ones that were odd and then get the squares of those.
Got it.
All right, so we'll go get squares of odds nums. So in this case, I'm going to use something that's a little interesting and kind of unique to F#. It's what's known as the pipe forward operator. So this is, if you're familiar at all with Unix pipes, where you just say, oh, the output of this thing goes into this thing, and then so on, you build a little pipeline. You can do that in F# here. So you can do that using this guy right here. Nice. This is the pipe forward operator. And so because nums, I'm going to think it's a list of integers. I think that's a pretty reasonable thing. Let's filter that out. Let's filter by isOdd, right? And so now we should have only the odd ones, but I'm not complete. Still need to pipe again. And so what I'm doing now is I'm shoving the output of this into what happens over here. So I'm doing list.map square, right? So just as a recap right here, we have nums. And notice that type inference, it was able to figure out that it's an int list because the compiler's awesome.
Yeah.
So nums gets shoved into list.filter, which takes isOdd, a function that we defined as a parameter, and then the output of that gets shoved into list.map, which takes square as a parameter, which is another function that we defined. So you can see we're getting kind of functional here.
Which is cool because what's happening is, like I was going to mention that when you say let square, let odd, there's no int, there's no double, there's nothing. But when it's doing the mod function, it knows that it must be a kind of an int.
Absolutely.
And then that gets passed into, when you say list.filter to isOdd, it says, oh, you're using isOdd, so this must all be int, and then everything sort of resolves type-wise.
Yeah, exactly.
Awesome.
And so there are a few occasions where you do need to actually tell the compiler, hey, this is a thing. Sometimes if you're using strings, if you're trying to use like a string library function, and you don't use like uppercase or something like that,
I see.
You'll need to inform it, but those are kind of few and far between. And some people, they do like to explicitly annotate the type and say like, oh, well, nums is a list of integers.
Right.
Because sometimes that's just their preference. That's okay, because you can do that.
Yeah.
So I'll just send that over the interactive window. We'll do get squares, am I typing this? Yes, of odds. And I'll do a little range operator here. So this is a list generated from 1 to 10. Send that off there. And ta-da, 1, 9, 25, 49, 81. That looks right.
Nice.
Yeah, I think that looks right. I don't know. Yeah, it's correct. So that's kind of cool. We can just kind of create these functions here, sort of ad hoc, and script them out, see what it looks like. And then we can say, OK, well, we're doing this for real now. So let's create some numbers. Say 1 from 25, because that's a bit more interesting than 1 to 10. And let's get the squares of those. So squares, well, squares of odds. Can't really think of a good name there. So I'll go get squares of odds numbers. Spelled that wrong. That's OK.
Hey, it works.
Yeah, so far it's still happy. But let's just do a plain old for loop. You know, I like for loops. Sometimes they're nice. You know, we'll do for square in squares of odds do. We'll do a printfn here.
And that's going to be
Right.
a square. Yeah.
Right, and so right there, I mean, this is just imperative programming here. This actually isn't functional, but that's fine, because it's a multi-paradigm language where you can do basically anything you want. If you want a for loop, you get a for loop. So let's go ahead and run that. And we will see, once it's compiled and run, that it worked.
There you go.
But that's still just, you know, I mean, that's kind of cool, but we want to see, like, you know, the number and what its square is. So just kind of ad hoc here, let's create a lambda function. So this is very similar if you're familiar with link in C# or VB, creating a lambda function. You can do that in FSharp too. So we'll do funx. That's kind of how you signify that this is a lambda function. And we'll just create a tuple. So we'll go x and square of x. Right? And so this time, you notice the type signature changed. It said it's no longer an int list. It's this little int star int list. That tells us that it's a tuple here. The compiler just figured that out already. And we notice here, I get a compiler error, because I'm trying to print out just a single int, but it says, whoa, where are they there?
Yeah.
That's a double int there. That's a tuple. Can't do that. So we'll just do this. Square squared is %d. And we'll change this to say num square. Right?
Nice. So it's automatically deconstructing the tuple that's coming in.
Absolutely. It's just already got it. So this is anybody who has been following C#7 and has been interested in tuple deconstruction.
FSharp again.
We already got it.
So is there any ways to make the font size bigger on the FSharp Interactive?
Ooh, yeah, I should probably do that, because that's probably difficult to read.
Yeah.
Yeah, I haven't actually tried to do
Is it
that
a
before.
right click or something? There's got to be like a right click up in there.
Maybe? No?
No. Well, there's probably an option, but we'll
Okay.
have to get to it later.
Yeah, we'll worry about that. And I'll do one more thing before I get back over to slides and talk a little bit about more why functional, why what that all kind of means. Because I just do want to emphasize here that this is a .NET language. So we'll go open system.text.regular expressions. So let's use a little regex here. We'll go let's message equal Seth is awesome and he is fun to talk
Yes, we don't have to blatantly lie on the telly. I mean, she's nice.
Let's just say super there, just so that you feel even better.
Nice.
And so we'll go let super count equal to regex dot.
Yeah, and there's everything that you would expect.
Matches. You got everything right here. We'll pass in message, and we'll pass in a little thing. There's super, and we'll say count at the end of that, and we'll go printfn. Well, we'll just print out the count. I won't type out a cute little message or anything. All right, and we'll run that.
And then we should see at the bottom a 1.
At the bottom, a 1.
There you go.
There we go. Super was mentioned once in there. So you're certainly not limited to system and regular expressions.
Sure.
I could go through everything in here, but I don't have enough time. So
effectively, you could, anything you are used to in .NET that's nice, you would be able to use in F# as well.
Absolutely. You have access to every single .NET library that happens to run on the version of the .NET framework that you're running on.
Awesome.
And with .NET Core, you have access to almost everything. It's because it's still alpha. That's not entirely true, but you can, for example, today with F# on .NET Core, you can grab newtonsoft.json from NuGet, and then you can consume that in some way, and you can put that in a library, have that consumed by a console app, have that consumed by a test library. And so there's a lot that you can do there.
Awesome.
So now that we've seen some code, let's talk about this. It's functional first multi-paradigm. Those are some big words, aren't they?
Yeah, it feels a little smart for me. Yeah?
Feels a little smart. Well, functional programming is kind of that first part. So functional programming is, it's not really that crazy of a thing. It's really just kind of more, hey, you have functions, and you have data, and you have value, and things are immutable, and if you want to call a function, you just call it, and functions shouldn't necessarily have side effects. Now, you ultimately do need side effects if you need to do things like I/O or things like that.
Sure.
I mean, real world has side effects, right? But when you have, like, this big system right here, and you got this little part that's side effecty, and this little part that's side effecty, but the rest is just a bunch of functionality where they talk to one another. That part right there doesn't necessarily have to have side effects.
I see.
And so functional programming, and F# specifically, takes the opinion that, for that bit right there, you need to be as functional as possible. And so part of that is immutability by default. This is, in my opinion, the most important thing that F# has. So immutability by default is just a really fancy way of saying that things don't change when you do not expect them to. So basically, mutability is explicit rather than always present. So in a lot of programming languages, you assign a value to something, and it can change at any point in time. Doesn't matter when. And if you have a system that's like 500,000 lines of code, you've got all these things possibly changing at all these points in time, you're probably going to have bugs.
Yeah.
And so if you wanted to be mutable here in F#, it's quite simple. You just say let mutable x is equal to whatever, and then it's mutable. You can change it like you would anything else.
Right.
But the majority of the time, you don't do that. You really only do that when you have to. And so why? Well, less surprises in program behavior. When something has a value assigned to it, and then it stays like that, you can always count on it being that value at runtime.
And I've heard that this is a huge problem, specifically like in multi-threaded or highly concurrent applications, that things are not mutable.
Oh yeah, absolutely. Because I mean, like one of the biggest problems with concurrency in terms of like anti-patterns is like relying on some global thing that multiple threads have access to. And if they all of a sudden change that thing, then you have a race condition, and good luck figuring out what went wrong. In this case, because it's always immutable, you can't have that. And so that also plays really well for distributed scenarios, like with I guess cloud computing. You want to run it across all these different machines. If you know that everything is immutable by default, you're not really going to be surprised about what happens. And so that leads to what's known as a pit of success when your code base gets larger. Basically, that's just as you keep adding more and more stuff, you're kind of forced to adopt a more correct design instead of an incorrect one, because the incorrect or more bug-prone ones are going to start feeling really awkward. But then the more correct ones, where values are just values, things are immutable, things only change when you expect them to, that comes naturally as you use the language. And that's really, really awesome for a big system of any kind. It doesn't have to be some fancy finance thing with tons of information coming in and out. I mean, this can just be a regular old web application where you just want to minimize the amount of bugs before you ship your product. And time to market is really important in that regard, and this is good for time of market.
So you're saying that it's going to take less time to develop, and it's going to be even better when it comes to mutability and concurrency and those kind of issues as well.
Yes. So when I say less time to develop, kind of the key thing there is, what do you think takes the most time when you're developing a big thing?
Probably debugging it.
Debugging.
Yeah.
Yeah. The bug word. You got a bug and you have no idea what's going on, or maybe you do, but it's like really difficult to track. There's a really difficult repo or something like that. You can eliminate a class of problems with immutability.
I see.
And so another one, something that we saw, was this thing called FirstClass Functions. Again, another big word. just a fancy word for saying that functions can be passed as parameters to other functions. You already do that in C# and VB today with a link, basically. Well, kind of, sorta. It's really an object
It's
that
the
pretends to
func
be.
of T, right?
Yeah. But I mean, that's basically what's going on here conceptually. And so that is a really awesome code reuse mechanism. So kind of an example here would be, say you wanted to see if a character starts with a vowel. I'll give you a hint. This is for Pig Latin.
Nice.
So in this case, I just chose to scan a vowel list for a match, see if that vowel list contains the first character. And to Pig Latin, I've just got a little if-else expression here. So if it starts with a vowel, then it's the whole name plus yay at the end. Or if it doesn't start with a vowel, then you call this little .NET string method that just kind of concatenates, takes the first thing off, concatenates the rest of the thing, the rest of the string, the first character, and then a at the end. And so I could call that here by just saying make them Pig Latin. We're given some names, and just pipe it into list.map to Pig Latin. Passing to Pig Latin is FirstClass Functions right there, because that's just a function that I defined up there, and I'm passing it in as an argument to this function. And so Pig Latin fruit is apple and banana. Pipe it into make them Pig Latin. You print that out. It says apple yay and banana bay.
Nice. That's fantastic. So the question I have, it's for people that are not familiar with the piping operator, it's also just a function.
Oh, totally. Yeah. All it does is it's just a fancy way of saying, like, in this case, list.map to Pig Latin also takes the names thing right there. So it's just a way of saying, like, instead of putting it on the right-hand side with potentially a lot of other parameters, you just stick it in the front. And then when you pipe that together with another thing, that's kind of like this, f of g of, that sort of
composition.
Thing. Yeah, exactly. And this allows you to effectively get rid of that, nested function call situation.
I see.
And it makes it a bit clearer. So there's another really cool aspect of it. And FSharp is a really powerful type system. So what I said before with type inference, that means significantly less boilerplate code, which you saw already. Like, for example, in this would infer that s as a parameter and the return type are both strings, because sprintf is a function that takes a string and it shoots out a string.
Got it.
Well, at least in this case, right? You could define it as this to be %d, and that would be an int, and then s would be an int, but the compiler would be able to figure that out, which is the really cool thing. FSharp also allows you to put certain runtime behaviors into compile time. So do you believe me when I say that?
I don't. What do you mean by that?
Okay, so an example that I'm going to have here is parsing and accounting for all possible cases. So int.parse, datetime.parse, that sort of stuff. If you just call the .parse methods, you get an exception, and that's runtime behavior. That's not compile time behavior. There's also the try parse, but that's like it returns a bool, and you have the out parameter.
Right, it's awkward.
Yeah, it's kind of awkward.
I'm not a fan of out parameters between us.
Yeah, exactly. And so there's this thing called the option of T in F#, which is kind of a way of representing that, I either have something or I have nothing. And so a way that you could kind of wrap parsing is I chose to have this little thing that says module parsing. Inside of there, I'll create a little helper function called tryParseWith, which takes in a function and a string. TryParseFunc is the function. So in this case, I'll do tryParseFunc s, and then the result of that I will match in a pattern matching expression, which C#7.
Yeah.
We already got it.
Yeah.
So in this case, it's basically just saying, well, tryParseFunc of s will return a Boolean and something, right? So in this case, if it's true, then I have a value. Then I can construct an optional with this sum value. And this is saying that the optional, inside of it, it has the thing that was parsed. And then the opposite case here, where it's false, and then maybe it gave me something, maybe it didn't. I don't really care. That's why there's the underscore there. I just say none. And that's the way of saying this optional has nothing inside of it.
And that's interesting because this will also eliminate issues with null.
Yes.
For example. And it feels like this is what this will do.
Yeah, you can also eliminate null in a lot of different cases with like a top-level null check, and then you construct an F# type that can no longer be null. And then so long as you only deal with that F# type from that point forward, you don't have null reference exceptions popping up.
Right.
So to kind of continue this, if I were to have this optional wrapper around parse datetime, I would just call tryParseWith with system.datetime.dryParse, and then a string, and then I could use it. And that's precisely how I'd use it right there. I'd call parse datetime pass in that case, that was my birthday last year.
Nice.
And then it returns an option of date time, which I must pattern match against at compile time if I want to use it. So I could choose to not pattern match against it, or in this case, you could also do an if-else expression, I guess. But then I wouldn't be able to use the date time. And so to get it, I have to account for both cases.
Absolutely, which is nice because you always need to or should.
Absolutely.
And the cool thing about this parse func is that you could also add a whole bunch of let parse int, let part whatever, and you could just pass that parse function in.
Absolutely.
Because all those functions have the same shape. They take a string and they output something.
Yeah, so here it is. If I wanted to add 10 more parsing functions, just 10 more lines of code.
Nice.
That's it. That's not a lot of code for quite a lot that you get in return.
Absolutely.
Yeah. So then there's another aspect of the powerful type system that it has. You can easily represent more complex information with discriminated unions, which are these recursive structures
like
that
OR
are
types, right?
Yeah, they're kind of tough, but when you have something that's tough, they come in handy. Like binary search tree. This is an inherently recursive thing, right? You know, there's either the empty tree or there's a node that has a value, and then there's a subtree on either side. And representing that without a recursive data type can get kind of awkward, and it can be kind of bug prone too. But because this supports recursive data types with discriminated unions, it's really easy. Here I just represented it in 3 lines of code.
Which is nice. And the option type is also one because it's some or none. Is that right?
Yeah.
Awesome. Cool.
And so there's also, this is one that I really like, units of measure for type safety. So sometimes things like ints have a contextual meaning. So like it can be a meter or a kilometer or some unit of measure, and if you happen to pass in the wrong value, well,
yeah,
too bad. And the compiler usually is okay with that in C# or VB because it's like, well, you passed me an int. An int is what I took here. So sometimes they have meaning, so you can do that with a unit of measure. So in this case, I'm defining a unit of measure for minute, and then I'm defining one for second. Then I'm defining a function called add minutes that takes in the current time, and it takes in some minutes that we're going to add to the current time. And notice that I specifically annotated the types here to say this int is a minute, and this int is a minute, and then I added them together.
Right.
And this is crucial because of this. If I tried to add 12 to 40 minutes, the compiler says, I have no idea what you're talking about.
Yeah.
And that's pretty powerful. And then if you say, oh, well, it's a second, it's still a compiler error because you defined it as using minutes instead of just, you know, not just integers and not just, you know, willy-nilly any kind of type. Only if you actually add minutes to minutes will it actually compile. And that's a really nice thing when you have those context-sensitive numeric values.
Absolutely.
So then that's kind of the functional side. But then what about the multi-paradigm side?
Sure.
So FSharp is fully object-oriented. It's got full OP support. You can do classes, interfaces, and abstract classes, inheritance. It's got generics. I don't think that's technically OOP, but like, you know, it's got all that great stuff. In fact, it uses the same generics at the runtime as C# and VB.
I see.
So if I were to define a 2-dimensional vector, for example, I could do this, saying type vector 2D, and then this dx, dy, this is basically like a constructor, kind of defining those values that you can pass in. That's optional, by the way. So this is what a private function would look like. You wouldn't be able to call this outside of vector 2D. And so this is what a public auto property would look like. So this is like the get set in C# and VB. And in this case, I'm just assigning it to dx by default here. This is an immutable public property. So this is like a read-only property in C# and VB. And this is a totally useless immutable private property, but the point here is that you have accessibility modifiers. So you can do public, you can do private, you can do internal, you can do all that stuff. And this is just what a member would look like. Remember this dot scale, so this would be scaling the 2-dimensional vector. I actually have a typo in there, but by default, it's a public method. And you can definitely change it to be private, you can change it to be internal, basically anything you want. An interface is also dead simple. In this case, ilogger defines a log method. And in this case, because interfaces, just as you would expect, you just provide the type signature. You don't actually have an implementation. In this case, this little string, arrow string, just says it takes a string, returns a string. And that's how you would create an interface. And if you wanted to have some inheritance, you just use the inherit keyword. And you can inherit by passing in parameters, just kind of the same way. It's very, very similar to C# and VB, just with a few slightly different keywords. So then there's another really interesting aspect of OOP in FSharp, object expressions. This allows you to implement interfaces on the fly. So this is something that I really like for mocking out a really simple interface when I'm doing unit testing. So I don't want to have to like make sure that I have all these interfaces like predefined on all these types, and building up all this stuff that, that gets in the way of me just writing some tests.
Sure.
So in this case, it's quite simple. If I were using XUnit, I'd open that up. You can imagine my project.services is a thing that I'm depending on, and it has a function called get and deserialize JSON. And because I'm following best practices, it uses dependency injection and takes in a little JSON service. So we'll create a mock JSON service on the fly here with this new iGetJSON service with. This is just basically a way of, this is how you actually implement it. And then I just say, well, this.getJSON with a URL gives me 42 as a little JavaScript object. And so then I would use that in a unit test here. So I have the fact attribute, which is what you use for XUnit. And then I use this little double backtick thing for the name, because that's just kind of a more convenient way for you to type out a whole sentence, and then the compiler knows that that's still a whole function, so you don't have to like Pascal case an entire sentence.
And that's just like a string that's like the method name.
Yeah, exactly. Exactly. That's really common in FSharp unit testing to do that, because then you can have a whole sentence instead of trying to give it a different name. So there's a fake URL there. I would pass the result right there, assert.equal. And so this right here, I'm just calling get and serialize JSON, passing in the mock JSON service instead of an actual JSON service. And this allows me to unit test without needing to have the service live.
Interesting. And so you're making a new type inline for your actual test.
Absolutely.
Nice.
Just doing it as I need it.
And not only that, but you could define only the members that are important, right? Because iGetJSON service might have more members. Cool.
And so just to be clear, this sort of thing, it's really awesome for simple interfaces. Now, if you have a really, really big interface, you'll probably want to use a third-party mocking library.
Sure.
Just because you get more stuff with that.
Sure.
And so lastly, as I mentioned before, runs on .NET and it is supported.
Nice.
So if there's a problem with the language, we will fix it. .NET language, access to all the libraries, call C# and VB code from FSharp, and you can do the inverse. Call FSharp from C# and VB. It's got tooling in VS, you got IntelliSense refactoring, everything Visual Studio.
And there's like FSharp power tools as well, I heard, that make everything a lot better.
Yeah, that's what I have running. It gives you some folders, some folder support, some other interesting like syntax highlighting stuff, and a bunch of other really awesome goodies. You get the same debugging support with C# and VB. I can show that where you can just step in and out of stuff, and it's just fine. An intensely devoted open source community. The people who work on FSharp open source are freaking awesome.
They are.
They are super active. They contribute to the language. They contribute to tons of different libraries that are really useful, and they will make your life happy when you use FSharp. And so the language compiler is open source. There's a huge collection of third-party libraries, many of which built, well, actually almost all of them built by community members. And as I said before, supported and actively developed by Microsoft on GitHub, and we accept contributions. So
Fantastic.
If you want to engage, we are happy to have you engage.
Fantastic. Well, it feels like we've talked a lot about a lot of sort of like language stuff. Do you have like an example of like a practical usage?
Absolutely. Let's extend a web app.
Oh man, it's like I almost knew what was coming. Let's do it.
Oh, wow.
Awesome.
So we got here, let's just close this guy really quickly. So just kind of as a background here, I'm just going to launch, this is the ASP.NET Music Store. I've set a few things up in advance. I'll have an example of everything. I'll have it up on GitHub, and then we'll probably find a way to put that in the description here.
Awesome.
So that you can all actually see this and play with it yourself if you're interested in the future. So in this case, this is the ASP.NET Music Store application. This is the sample app that we have for ASP.NET.
Okay.
It kind of shows you sort of an end-to-end of everything you can do with ASP.NET. So in this case, there's a music store, and here's some albums. The Best of Men at Work, Ring My Bell, Ride the Lightning is a Metallica album.
Nice.
It's kind of fun. So imagine if this was our business, and we said, okay, we want to collect some analytics here. month of December is probably going to be big in terms of shopping. We want to see like what people are actually looking at. Like, are they looking at the Beatles' Revolver more, or are they looking at Metallica's Ride the Lightning more? This is useful information for us to know if we want to actually change what we're doing for the better. And so that is kind of this analytical thing where we're just going to be collecting information about, you know, when someone views the details of an album, we might want to see the ID, the name. Maybe we'll want to know if it was cached in the database.
Sure.
And then maybe we'll want to know the time that it was accessed to, so we can kind of correlate all this different stuff.
Got it.
So as I set a few things up here before. So the first thing that I'm going to do here is there's this project here called musicstore.cassandra. Musicstore.cassandra is where I'm going to be talking to a Cassandra cluster that I have on the Mac here running in a Docker machine. So this stuff that you see right here is a Cassandra cluster. And I've set it up to talk to us over port 8881 and this IP address.
Nice.
Okay, so first thing that we do, I have some stuff pre-commented out here because this would be a pain to type live, this specific stuff.
I'm with you, bud.
So notice that I also have a few references here. I have a reference to Cassandra. If we were to look at what the NuGet packages for this looks like, this is the official Cassandra driver. So this is a C# driver.
Sure.
This is they didn't write this for FSharp users yet, but you can still use it.
Absolutely.
Which is pretty nice. This is a dependency on the Cassandra driver, so that's why you see it there. So first thing, let's go ahead and open some namespaces. Open Cassandra. So this is going to actually give us access to the driver there. And so what I had said, we had a few things that we cared about there. We wanted to get the ID of a particular album. We wanted to get the name of the album. We wanted to see if it was cached in the database. And we also wanted to get the timestamp of when it was actually viewed.
So to be clear, what we're doing is we're writing a whole new subsystem of the website.
Yeah.
Then anytime someone clicks on something or looks at something, we're going to push it off to Cassandra to do analytics.
Absolutely.
Cool.
Yeah.
Okay.
So this is going to be using a Cassandra data cluster that's totally separate from the Entity Framework SQL database thing that we got going on displaying stuff.
And it's running in a container inside of your Mac.
Oh yeah, and we have Cassandra support on Azure, if I'm not mistaken. So you could put a Cassandra cluster up there and use it, and it'll be good to go.
Awesome.
So let's define a data type, because that's what we actually want to have here. So we'll go album details. So defining a data type here, we said we wanted an ID, so that's an int. We said we wanted a name, so that's a string.
We want to know if it was cached. I think it was the last one.
We wanted cached. That's a bool. We also want the time.
That's right.
Yep. So we'll do a date time offset. Okay. So that's pretty cool. So we have a little type here. Now we're going to have to actually use it. Let's define an interface, because if we have time, I might be able to show how to mock this stuff out and unit test it for real. But using an interface is always kind of nice. So we'll go I Cassandra repo here. And so defining an interface, as we said, uses the abstract keyword. Remember, syntax highlighting is a little funny there. We'll go send album details, and we will provide a row set. I remembered that row set. So just as an FYI, row set is the thing that the Cassandra driver returns. So when you try to insert something into a table in Cassandra, it returns a row set that just kind of signifies, hey, this is what we inserted.
Got it.
And so I'm just basically using that same type signature here because it's always good to just sort of retain that information.
And the squiggle was there because the type wasn't all the way done yet.
Absolutely. So then we'll add another member here. Extract member. Let's call it get all. In this case, takes in unit, which is a way of saying void. That's effectively doesn't take in anything. And a row set, because a row set is what's returned when you access something from the database. So iCassandra repo, we got an interface. We should probably implement it. So let's go ahead and do that.
Now, is the fact that there's abstract members in the iCassandra repo type make that an interface? Because it has nothing to do with that you named it iCassandra repo. Okay.
Yeah, no, you could name it whatever you want. It's just that's the .NET convention. So we usually always do that sort of thing. It's this right here, the abstract member and the type signature.
Got it.
We can see right here, it's able to figure it out. It says it's an interface. It's got get all and send as things that you need to implement.
Cool.
So type Cassandra repo. Let's give us a cluster. Cluster.builder. We'll go dot add contact point. So this is part of the Cassandra API here. So it takes an IP address. We need an IP address. So let's go ahead and do that. IP address, and here I'm going to annotate it just for clarity here. So IP address is a string, and I know it's also going to need a port. So we're going to give it a port. So in this case, I've defined that when you instantiate a Cassandra repo, you need to provide an IP address and a port.
Sure.
That IP address and port is going to correspond with what we have right here. So in this case, I'll go IP address. We'll go with port, not int, port. And then we'll do .build. And so this gives us our sort of handle to the Cassandra cluster that we have here. And so what I'm doing right here is these are private functions inside of Cassandra repo here. Let cluster, you're not going to be able to call this outside of the actual type.
Repo, yeah.
Yeah. And so we'll go, and repo is short for repository.
Sure.
Just in case people are curious. So we'll go session. So they also have this thing called a session, which is your way of just interactively interacting with it. So we'll go cluster dot. Is it build session or is it get session? I actually forgot here. Connect. That's what it is.
There you go.
Connect to the session. That's the one I was looking for. And so another thing that we're going to need to do here is what if we haven't actually created the table in there yet? We should probably do that.
Yeah.
And if it doesn't exist, create it, do all that kind of stuff. So this sort of first-time setup situation you can do is really simple here, the do keyword. And kind of within this block that I've defined here, this is something that kind of the first time that something's instantiated, it will call this sort of stuff.
Got it.
And so these are the things that I've commented out, because there's some hard-coded strings in here, and I didn't feel like typing those out.
And we thank you for that.
Yes. So I'm going to go ahead and uncomment that all out. So basically all I've done here is I've said that in this session we're creating a key space if it doesn't exist, and we're calling it demo. This other stuff is like replication, data consistency sort of stuff. It doesn't really matter for the demo. Key space is very similar to a schema in SQL Server.
Got it.
So a schema has certain tables, a key space has tables in Cassandra. And so then we're going to execute it. And notice that I'm piping things into ignore.
Right.
So this is because execute returns a row set in every single one of these things. But I'm not actually using it, because the fact that a key space was created isn't really useful to me. And so I'm going to explicitly ignore it in this case.
Got it.
And that's fine, because if I didn't know what I was doing, and if instead I were just kind of trying to silently ignore it,
it would be unhappy.
Be very unhappy. It says the expression, it says, uh-oh, I don't know what this type is. You've done something here that's confusing me, is what the compiler says. So we'll just put that back in there. Okay, and so that's the setup here. So then we're using that key space, and then we're creating a table. There's an int, there's an ID that's an int, a name that's text, whether or not it was cached, which is a Boolean, and the time that it was accessed, which is a timestamp. And then we're going to create a primary key that's kind of composed of the ID and the time it was accessed. And then this clustering order by thing is kind of a way that you can order across clusters. I don't really know a whole lot about Cassandra, so I don't think I'm going to be an expert here. But to get to the meat of this all, we need to actually implement this interface. We'll go Cassandra repo with. Actually, I feel quite dumb now, because there we go. It was the interface keyword. So in this case, I'm going to implement the send function. Details. So this takes the album details that we have there. So what we're going to need to do is insert into that table. So Cassandra has this thing called SQL, Cassandra query language. Ain't that cute?
That's hilarious.
So we're going to do string dot format here. So this is a .NET function that I have here. You know, I'm just going to take what I actually had here and just copy it over because I'm probably going to forget something as far as what those hard-coded strings are. And instead, I'll just talk about what it was.
Got it.
Because I would have screwed something up. Okay, so I will uncomment this stuff out here. To wait for the cursor here, I would have used some of the Mac key bindings, but they do funny things in parallels. So in this case, it's quite simple. I've just taken a details object, and based on how I'm dotting into it, I'm saying .id, .name, .cache, .time, and then to Unix time milliseconds.
It knows the type, yeah.
Yeah, so it's able to figure out that this is what it is. And so now I just need to execute this query. So the way I'll do that here is I'll go session.execute SQL. And so now this matches this .send. So you notice there's no red squigglies inside of here anymore. Now there's one in Cassandra repo because I haven't implemented everything. But I fulfilled that particular contract. So now I'll do the other one. This get all equals. And this one, it's really simple. I'm just going to do session.execute select star from demo.album details. Yeah. And so that's just another SQL query in there. And now it's unsquiggled. It's happy because I've implemented the interface. So let's get this thing to actually talk to Cassandra because I think it's fun to see that happen. So in this case, actually, I need to do one thing here. So I'm opening an interactive window. I'm going to go ahead and reset this thing. And so what I'm going to need to do in here is, notice how I clicked on this Cassandra reference right here? I need to send that to the FSharp Interactive. So you can do that with send to FSharp Interactive. And so now it referenced precisely where on disk that DLL from that NuGet package happened to be.
Nice.
So I can then use it. It's a pretty handy little thing when you're scripting stuff out. Okay, send that over. And I sent that over with Alt-Enter. And so now it's able to say, oh, well, I got this album details, got this iCassandra repo, and I have the actual repo. So let's go repo. Let's call it iRepo here. Equals new Cassandra repo. And we'll pass in the IP address, which I actually had saved down here, because I don't remember what that actually is. So this might be a little hard to see because I couldn't figure out the font here, but I'm just passing in the IP address here, and then it's 8881 as that. And so we'll instantiate that, and we'll cast it using a cast operator to an iCassandra repo. Right?
Nice.
So now I got an iRepo that I've actually instantiated and I can use. So let's go iRepo dot send. We'll send it a new album details. So we'll go ID equals, let's call it 1. Name equals Seth's awesome singing album.
It's quite good.
Oh yeah.
That's why it's the first one in the database.
We go cached. Of course, this was cached.
Sure. Everyone's looking at it.
This is
That's
everybody's.
the one, yeah.
This is going to be running on everybody's radios during Christmas time. And then finally, we want time. That's going to be date time offset. Yeah. Dot now. Okay. Oh, did I not? I bet I know what I did. I know exactly what I did. So this is a funky little error message here. So I didn't escape things properly, so I'm just going to misspell that.
Nice.
There we go.
Beautiful.
So now it's sent. And so the way that we know that that actually worked is I'm going to connect to that Cassandra instance. And I'm going to use SQL SH, which is an interactive SQL thing that we got going on there. We'll go select star from demo.album details. Ta-da!
There it is.
It's inserted into the cluster. So just to clarify here, from a VM running on my own machine, I've sent from that process into another VM running on my own machine into a Cassandra cluster. So that's pretty neat.
It is. We got about 10 minutes to go,
Okay.
but I think the cool thing was that you were able to not only just write this, but you were able to test it in the interactive window as well. Which was pretty
Absolutely.
cool.
Yeah. And so let's just show how you hook it up really quickly,
Let's do it.
because that's some dead simple stuff. So what I did here is I just created an external service. So the first thing I'm going to do is take this guy right here, what I've called this analytics controller here, and I'm just going to take this. I didn't actually have it there. Let's just instantiate this really quickly. This is going to be nice and easy. Music store.cassandra. I added a reference to this. So this is a C# project. This is a Web API 2 project. And I've added a reference to my FSharp project. Okay. And so what I'm going to do now is I'm going to instantiate a new details object from what I get in this HTTP put that I got going on here. Go var details equals new album details, and hey, look, we got IntelliSense, and you can see exactly what's going on here.
Too.
ID, name, cached, time. And then we'll need to have a little repo here. We'll go private, read only, Cassandra repo, call that a repo here, public analytics controller. There we go, that's what I'm looking for. So in the constructor, we'll just instantiate that repository. Cassandra repo, we're going to pass in
192.168. 99.100. There you go.
There we go. Nice to have that interactive window so that
Sure
you can,
is.
have what you actually typed and use it.
And then
So
repo
now
dot put, right?
We're
Or
going to repo. I called it send.
send. That's right.
I guess we probably could have called it put.
Nah,
but
send works.
yeah, it's okay. And hey, look, it takes in a details object. Let's go ahead and do that. All right, and then we'll go return. Oh gosh, how do you create it at route? That's the one. Create it at route. I always kind of forget what I'm actually supposed to have there. So we'll go under send and details.
And then there's the only error is you cropped off an S on the detail on
Oh.
repo.send.
There we go.
There you go.
Cool beans.
Fair programming.
Yeah. So now we'll go ahead and launch this. If I can right click, there we go. Start a new instance here. So we should see an error page. That's okay. That's just because I haven't defined a home page for anything. So
Got it.
it's going to be like, oh, well, because it's a web API. It's just a process that runs and accepts stuff on a socket. So, so I'll also launch Music Store here.
And see, the music store is calling into this API.
Absolutely. And
Got it.
actually, I'm not going to launch the Music Store right now because I missed something. Because I am a smart person who loves to miss things. We need to actually send it.
Oh,
So
yeah,
in
of
this
course.
case, I'm just tracking to see if it was cached. If it wasn't cached, I'm setting that to false. I'm saying that it's true by default. Give us the URL here, and we'll use HTTP client to actually do a post and send that puppy out.
Now it's going to do something.
Yes, there we go.
And the Cassandra web API is already running as well, right? Okay.
Absolutely.
Yep, there it is.
Or is it running, actually?
Yeah, it's forbidden, which means that,
okay.
which is good, right? Because there's nothing else.
Well, you know, actually, I'm just going to relaunch it because
Just in case.
Yeah, just in case. I'm not going to hedge my bets on something still working. There we go. Okay, cool. So we did the best of men at work. That's fun. Let's put a breakpoint in here. Let's
Just to
actually
make
see
sure,
what's
yeah.
going on here. Analytics controller, put a breakpoint in there.
Nice.
We'll do this. Ride the lightning. Hooray!
Yes, we're in there.
We got an ID, a name, cache, time. Let's go ahead and step over before we run out of time. Let's step inside. Oh man, we're in F# right now. We're debugging in F#.
Crazy
What's
town.
this?
We're in crazy town right now.
Are you telling me that you can do F# for general purpose development? Yes, absolutely. And so here we are. I'm really passionate about this whole use F# for everything. And so it all just worked right there. So I'll continue. And then we'll do this. We'll go up here. Whoops, wrong one. I think I actually need to, I'm curious if this will still work there. There we go.
There it is.
So this is the stuff that we just clicked on. We got Seth's awesome singing album. That's my personal favorite.
Of course.
We got Metallica's Ride the Lightning. We got the best of men at work. We can see we have the times that they were accessed, whether or not they were cached, all that kind of stuff. This is all working. And one thing I'd like to point out here is how much time did we take doing this?
Yeah, and most of it was me asking dumb questions. Now, the cool thing about this is what I'm noticing is that you don't, sometimes I feel like, well, I got to write everything over in F#. What you're saying is pick specific parts of the application that are new. You could totally go and make a microservice, for example, in F#, or you could make another service in F# that actually uses functionality that's new without having to sort of go back and redo everything else.
Oh, absolutely. I mean, here it's just, this is just another project in the solution. Most of these projects are C# projects because that's just what it came with.
Sure.
And so this is kind of the example. You have an existing system written in another language. You don't have to rewrite stuff. You just write what you need to, use the best tool for the job. In this case, I think F# is a great tool for this sort of stuff. And I think that if you have these sort of problems that you're trying to solve, you should consider using F# for that kind of stuff. Because here I'm accessing .NET Framework libraries. I'm pulling NuGet packages down and using a driver from the DataStax company in their Cassandra data storage.
Sure.
I'm creating stuff in F# and consuming it in C#. I'm having web APIs talking to one another. You know, this is all just normal general purpose development stuff, and it's really easy to set up. And I mean, look at this, 53 lines of code.
Yeah, it wasn't bad. So in the last about 60 seconds to 90 seconds, where can people go to find out more about, for example, what you do, and then also about F#?
So if you want to find out what I do, go to GitHub.
Nice.
Seriously, github.com/CarterMP. I actually do not have this in the slide deck. I will be on the Visual F# repos. You can access my Twitter handle at _CarterMP.
Oh, nice.
The original CarterMP was taken. I might need to
we need to
take
find out
some
who that is.
legal action there.
Yeah.
Yes, but please try out F# for your next project if you think that what you saw here would be useful to you.
Awesome.
Yes.
Well, this has been very informative. We've actually started with F# in general. We took a half hour to look at F# in general, what it's like, how it's going, and then we actually dove into an actual practical logging application using Cassandra without really having to rewrite anything else.
Absolutely. And another thing, so later, probably today or maybe tomorrow, we'll update the description in the video, and I'll be putting this application up on GitHub.
Nice.
And I'll have instructions for how you set up your Cassandra stuff, how you talk to it, how you basically get everything working to the point where you could just start adding code. And you can use that as an example for doing this sort of work.
Awesome. Well, we are going to call it for this one. Thanks so much for spending some time with us.
No
Again, there is one more session coming up. You do not want to miss it. It's a surprise, or maybe not because we have a schedule and I just forgot and I tried to cover. Thanks so much for watching. We will see you on the flip side. Take care.